Hello everyone, welcome back to my YouTube channel Z2H classes. In this video, we will again solve few previous year question from BARC which are purely memory based since BARC do not publish their question paper. So here our first question is in superconductor electrons form Cooper pairs. Electron forms Cooper pairs. This pairing is due to, so Cooper pair is formed due to interaction of electrons with lattice. So your correct option will be C. Phonon. You may learn in BCS theory about electron phonon electron interaction. Electron phonon electron interaction. And when phonon come, so phonon is nothing but quantized energy of lattice vibration. Okay. Now, second question, which is also direct question. I already wrote something. Which among of the following is example of symmetric top? So here symmetric top is CH3F. Okay, here CH4 methane, which is spherical symmetric, HCl hydrochloric acid, it is linear, and CH3F fluoromethane, it is symmetric top. So your correct option is C. Now third question, if a body moves under a potential V of R is equals to minus alpha upon R, where alpha is a constant and R be the distance from origin, its path will be parabolic if total energy is positive. Because whenever your path is parabolic, the total energy must be positive. Because in parabolic shape, it is unbounded state. Okay. And if your shape is ellipse or circle, then it is bounded state. So you can remember like this. In bound state, the shape is ellipse or circle. If the shape is ellipse or circle, then it will be bound state. And you know what is bound state? Bound state is a state in which energy is negative. That is something bind, something is bounded. So its energy must be negative. So energy will be 0. And for bounded system, energy is negative and the shape is ellipse or circle. And for unbounded system that is free, you can say, unbounded system or unbounded state where energy is always positive, the shape is parabolic or hyperbolic. So this is very interesting concept about shape. So for ellipse or circle, energy is negative, and for a parabola, the energy is positive. So here you are given parabola. So your correct option will be positive energy. Now fourth question. This is one of the best question. You have to remember this directly also. Which is the correct expression for the partition function of one-dimensional quantum harmonic oscillator? So the question is partition function of one-dimensional quantum harmonic oscillator. This question is several times asked in GATE and CSIR net also. The direct concept is used. So if you follow my previous videos, then you know how to find partition function. So partition function can be found like this. The formula of partition function Z can be given as summation e raised to minus beta e. And here your system is one-dimensional quantum harmonic oscillator, so energy will be n plus 1 by 2. So I write here that is for one-dimensional quantum harmonic oscillator, energy is n plus 1 by 2 h cut omega. If your quantum harmonic oscillator is three-dimensional, then here instead of 1 there will be 3, but here we are given that our quantum harmonic oscillator is one-dimensional, so I take 1 by 2. Now substitute the value of energy here, so you will get summation e raised to minus beta, and instead of e I put n plus 1 by 2 h cut omega, and this is sigma operates on this n. Okay, so I put limit of n here, that is n from n is equals to 0 to infinite. Okay, now you know n is equals to 0 is ground state, but now we calculate partition function. So first of all put n is equals to 0, so you left with e raised to minus beta h cut omega upon 2. Then you have to put n is equals to 1. N is equals to 0, 1, 2, 3. In this manner you have to take values of n. So first of all I have put n is equals to 0. Then I put n is equals to 1. So I will get e raised to minus, if I put 1 here then it will be 3 by 2 minus 3 by 2 beta h cut omega. Now I put 2, so I will get e raised to minus 5 by 2 beta h cut omega, and so on and so forth. Okay, now I take e raised to minus beta h cut omega upon 2, or you can say 1 by 2 beta h cut omega common. So I left in bracket with this is taken common, so it will be 1, and from this term minus 1 by 2 h cut beta h cut omega is common, so you left with e raised to minus 1 by 2 is taken common, so you are left with only e raised to minus beta h cut omega, and then here also you have taken 1 by 2 common, so you left with here e raised to minus 2 beta h cut omega, and so on and so forth. Now this e raised to minus beta h cut omega upon 2 I take take as it is, and in this bracket term I ignore or I neglect the higher order term because it will be very small. So I left with 1 plus e raised to minus beta h cut omega. Now I take this bracket in denominator. So if I take this bracket in denominator, then its power will be minus 1. So what will happen? E raised to minus beta h cut omega upon 2 divided by, I take whole bracket in denominator, so it will be 1 plus e raised to minus beta h cut omega raised to minus 1. So now using binomial theorem I will get what I have to do. I have to do just multiply this negative instead of here. So I will get e raised to minus beta h cut omega divided by 2 upon 1 minus e raised to minus beta h cut omega. So this is your partition function for one-dimensional quantum harmonic oscillator. Please remember it directly also. So e raised to minus beta h cut omega by 2 upon 1 minus e raised to minus beta h cut omega. So your correct option is A. Okay, this is very important. Now, fifth question, in which we are given that commutation relation. Find commutation relation of x with commutation of x h, where h is Hamiltonian of free particle of unit mass. So now, first of all, you are given commutation relation of x with commutation of x comma h. Okay. So what we do? First we will find this commutation relation x comma h. Okay. So we will require Hamiltonian. So Hamiltonian is nothing but kinetic energy plus potential energy. Kinetic energy plus potential energy. So it will be kinetic energy of free particle P square divided by 2m, and potential energy of a free particle is 0. Okay, because it is free particle you are given in question. So your Hamiltonian will only consist of kinetic energy. So your H is P square upon 2m. So I substitute first of all in this commutation bracket. So it will be commutation of x comma h is equals to x, and I substitute value of Hamiltonian here, then it will be P square upon 2m. Now this 2m, can I take outside the commutation bracket? So I take 2m outside the commutation, so it will be 1 by 2m x comma p square. Now this p square can be written like this 1 by 2m as it is, and then x comma p into p. Now I put formula of commutation relation, that is this multiplication can be written as x comma p plus x comma p, x comma p plus x comma p. Okay. Now okay, we have to x comma p, so I have to put p also, p here also, p, and here also I have to put p. Okay, now it is right. This is nothing but the relation, you know. I write here, if you have a comma bc, so you can write this as a comma b, c outside, and plus a comma c and b inside. Sorry, b also, this time b is outside. So I use this formula. Commutation relation of a bc is equals to commutation relation ab c plus b commutation relation of ac. I used this formula here. This formula I used here. Okay. So I hope now you get it, that how I did. Now also I have to give you x comma p relation, or I think you know this from elementary quantum mechanics. That is x comma p is given as x comma p is equals to I h cut. This is your commutation relation. No? This is your commutation relation of position and momentum. So I substitute this value here. So it will be 1 upon 2m. This p as it is, and this x comma p will be I h cut. So it will be I h cut p plus this is also I h cut and this p as it is, so it will be also I h cut p. Now 1 divided by 2m, so it will be 2 I h cut p. So this 2 and this 2 will cut down and you left only with I h cut p over m. Okay, but do not forget, this is your just x comma h, and what you have to find? You have to find x of commutation with, you have to find x commutation x comma h, you have to find this. So now I put this x, and the value of commutation relation of x comma h we have derived is this, and what is this? This is I h cut p divided by m. So now I h cut upon m is constant, so you can take it outside the commutation bracket, so you left with I h cut over m and commutation x comma p. And what is x comma p? X comma p is I h cut, so I h cut over m, and this x comma p also gives I h cut. So I h cut will be I h cut will be I square h cut square over m, and this iota square is always minus 1, so it will be minus h cut square upon m. And since you are given that mass is unit, so your commutation relation will be minus h cut square, and unit mass, that is means 1, so it will be minus h cut square. So this is your correct answer. So your correct answer is B, minus h cut square. Okay, that is for today. Thank you.